Okay, so in this video we are going to start our work on solving quadratic equations. And in this chapter we're actually going to introduce you to three methods for solving quadratic equations. In today's lesson we're going to talk about the square root property. Okay, so just a couple of reminders here. As you know, a quadratic equation in standard form looks like this: ax squared plus bx plus c equals 0. And of course, a cannot be 0 because we need that x squared term. Okay, and so this is the definition of a quadratic equation in standard form, and we've used that in previous work, right? Okay, now I'll talk to you about the square root property with the first example. So let's go right to the first example. Okay, so here we go. We're solving x squared equals 144. So you've got an equation. You want to solve for x. Okay? And so what are we looking for? Well, we're looking for a number that we square to get 144. And if you said 12, then you are absolutely right. Okay? So 12 squared is 144. So definitely for the solution to this equation, x squared equals 144, 12 is definitely one solution. But it isn't the only solution, is it? You do know that also negative 12 squared is 144. So when we are solving this quadratic equation, degree 2 equation, we are going to expect these two answers. Okay? So how we do how the square root property method works is you have to set up the quadratic equation in the correct format first. So standard form, that's that form we looked at up here where you had ax squared plus bx plus c equals 0. Notice that in standard form, you always want that 0 on one side, right? But when you're working with square root property, you actually want to isolate the term that has the x squared. So in our first example here, that's already done. Okay, so the first step is to isolate the x squared, and then the second step is going to be that we're going to take the square root of 144, right? So when we take the square root, so it's kind of like we're taking the square root of both sides, right? Square root of x squared is x, and square root of 144. But here's the thing. This symbol, as soon as you put the radical and put the 144 under it, that represents that positive 12 answer. Okay? So in order to get the negative 12 answer, we are going to actually put a plus or minus in front of that square root. Okay? And then that will give us our two answers, our x equals positive 12 and our x equals negative 12. Okay, all right, so look at number 2. Number 2, notice that this number 2 is in quadratic equation standard form with the 0 on one side. But if we're going to use square root property, the first step is going to be that we want to isolate the x squared. So that's going to be the first step. So that means, of course, that we're going to add the 56. So x squared equals 56 step. So that's our first step, right? Then the second step is we're ready to do the square root property. And then we have to remember that plus or minus. And we discussed why in the first example, right? We're going to get those two answers, that square, to get a 56. Okay. Now, you might be feeling a little nervous about 56 because it's not a perfect square. That's okay. We're just going to use our properties of radicals that we did in our last chapter to simplify the radicals. Okay, so x equals plus or minus square root of 56. That's the step in which you're actually applying the square root property. Okay, with the plus or minus. So that's step number 2 is the one that we just looked at right here, right? Now, step number 3 is that you want to simplify, and of course, that's where I'm telling you or reminding you that we need to look at this radicand 56 and see if we have any perfect squares in there. And so we need to do a little factor tree, right? And so you probably remember 8 times 7 for 56. And then 8 is 4 times 2. And then 4 is 2 times 2. And because we're looking for square roots, we're looking for groups of 2 factors that are the same, like these two 2's, right? And so then we take the square root of these two 2's, which is square root of 4. That means a 2 comes out of the radical. So x equals plus or minus the 2 that came out of the radical from this group, square root of this 4 here. And then we got to multiply this 2 times 7 here. That's left in the radicand, which is square root of 14. So you've really got 2 answers to this original quadratic equation. Positive 2 square root of 14 and negative 2 square root of 14. I'm putting it in roster form. Okay? All right, let's look at the next problem. Number 3. Okay, so again, a reminder for you is that we want to isolate the x squared. So that means if you're looking at this and saying, let's divide by 10, then you're absolutely right. So divide by 10. So then x squared equals negative 64. And now we're going to apply the square root property to both sides of the equation, right? So that means that we're taking, if you want to think of it as taking the square root of this guy, but over here, for sure, we need a plus or minus square root of negative 64. Okay, so that's, let me rewrite that. X equals plus or minus square root of negative 64. Okay, we got to simplify that square root of negative 64. Do you recognize that? If you said complex number, you're absolutely right. So this will be 8i. Remember, this is square root of negative 1 times the square root of 64. And this square root of negative 1 is an I, and this is an 8. So x equals plus or minus 8i. So your 2 answers are 8i and negative 8i. 2 pure imaginary complex solutions. Cool. All right. So, yeah. Matter of fact, did you notice that we're getting some different kinds of solutions with these quadratics? In equation number 1, we got those beautiful integers, 12 and negative 12. And so I'm just going to remind you that those are rational numbers, numbers that can be written as fractions, okay, such as 12 over 1 and negative 12 over 1. But then in the second equation, do you notice we got that 2 square root of 14 and that negative 2 square root of 14? This square root of 14, when you put it in the calculator, that gives you never-ending, non-repeating decimal, right? And do you remember that those square roots of non-perfect squares, those form irrational numbers, kind of like pi, all right? So in this particular, in example number 2, our quadratic gave us two irrational solutions. But then in example number 3, we got 2 complex solutions. And not only complex, but conjugates. Right? They're conjugates of each other. Oh, wow. And if you're remembering that they're pure imaginary because the real part is 0, then you're really remembering a lot. Oh, that's the word imaginary. Okay, let's look at number 4. Number 4, definitely we need to isolate that y squared. So we're going to add 13 to both sides. And then what do we got here? 392. And then we're going to divide by 8. So you definitely want to isolate y squared. That's really important when you're using square root property. Okay. Okay, and so then 8 goes into 392 49 times. And then we're going to take the square root of both sides, right? So use our square root property, y equals, not forget the plus or minus. So plus or minus square root of 49, which we know is a perfect square, and it's 7. So y equals plus or minus 7. And remember that you can check these, right? So you are getting two answers again, a positive 7 and a negative 7. And again, to check it, you would substitute in, right? So let's actually use our, it's been a while since we've used our calculator to check something. So, okay, so we're going to, well, you know me, I like to use the stow key here. So I'm going to put 7 and stow it in x, and hit enter, and then I'm going to type 8x, x is our y, right? Squared minus 13, and then let's see, we'll get 379. Okay, boom, and so that checks.